Dear participants, welcome to second International Conference on Advances in Electrical Electronics, Energy and Computer Sciences. We are in session 1 now, and we have 8 papers to be presented in this session. So each participant will have 10 minutes to present their studies. So the title of the first paper is Industrial Symbiosis Improvement with Digital Twins. I think the author is here.
Yes.
Okay, you can share your screen.
Okay, thank you very much.
You're welcome.
I think you can see.
Not yet. Yes, now we can see. You can start.
Okay, thank you. Okay, greetings from Macedonia. I'm Professor Alexander Anastasiou from National Balkan University in Skopje, Macedonia. My paper is Industrial Symbiosis Improvement with Digital Twins. Just a moment to change the slide. Okay. So first, let's see what is industrial symbiosis. Industrial symbiosis is very hot topic today because it trying to minimize the waste, different kind of waste in industry with sharing of waste from one type of industry as raw material to another type of industry. And that sharing has some barriers that are problems in creating of those industrial symbiosis. Those barriers are mostly in interpersonal trust between business partners in industries. You know that one industry or one factory need to share some information about their production system to other company, and those informations can be a little bit risky for all those companies that are sharing to not leakage in some other uh, in some other uh, company that is competitive to that company. So the trust and some sharing of information of exchange are very problematic. That those problems can be avoided with using of computer engineering solutions. One of those computer engineering solutions are digital twins. So let's see now what are digital twins. Those are uh, virtual copies of physical systems. They are more than simulation. They are dealing with updated data that are real time data, and the whole production is lead to based on those real time data. So digital twins in general are used inside one company as a part of Industry 5. But in this case, industrial symbiosis, we have two or more companies that exchange materials, energy sources, etc., be used in that part that is common for all those companies that create that industrial symbiosis. Here you can see the figure that here is production process that is connected with physical system data and virtual copies that are digital twins. So here are equipment that is used, different kind of sensors, smart devices, database management system that is all the time connected, connection between the physical system and the digital twins. And digital twins as a virtual system must always forecast all those data, forecast the system, what will happen in next few minutes, next hour, etc., to lead the system in appropriate way. So this is a software system architecture for digital twins, and Here is the physical object. From physical object, we are taking a data, timestamps, and we determine what are the behavior of the data, and we are doing synchronization and aggregation of all those data. Based on all those data, we determine the behavior of the system, and we can forecast what will happen with the system if some malfunction happened in that common part of the system. So, for implementation of digital twins in industrial symbiosis, we can suggest few steps how to do that. So, first step, there must be established industrial symbiosis or eco-industrial park where companies have already agreement to share sources between themselves, and there is a part that is common for those both companies. We need after that, we need specification of all processes that connect units in industrial symbiosis or eco-industrial parks. Practically, we determine what equipment is used, what kind of data we need to have to understand and to use for sharing of those materials. You know that if I'm sharing some material to other company, uh, I must have data how much material I send to that company, and the other company must have the same data how much material they get from me. So that are parts that are very important for sharing of material in business. You know, when you have exact values, you have no problem. But if you have some uh, equipment for measuring of those sharing sources or sharing materials, different one in another factory can have two different values, and there will start some problems. What is the real value of shared materials? Because they need to pay, I need to get payment from them, etc. So when that is determined, what kind of equipment is in the common system between those companies, we need determination of bottlenecks and to find the negative factors, preparing of high digital twins references. So we need to find the points and parameters and virtual model of that common system. Later, we need to prioritize of integrated part, and we need to make data validation of extracted parameter data. With extracted parameter data, we are creating a mathematical model and make a simulation. So as you know, in mathematical models and simulation of, with using of simulation of those models, we can determine or we can make a validation of that model that does that model is close to the real or it has very high error regarding the real data values. So we are selecting the best model for simulation validation, and from those model with connection, that model with sensors and other equipment that we need for digital twins, actually we are creating that digital twins architecture and model. After that, we are determining the benefits, what is the added value, economic and quality benefits. Sometimes using of digital twins can mean that we need to have too much expenses and less profit. In that case, businessmen will not invest in that kind of project. So here we are determining does that project can be applied in the reality or not. The next step is project proposal, analyzed by economic, environmental, social, and production benefits. And if there are find good benefits for all these four areas, we can continue with real implementation of digital twins. In digital twins, we need to connect also business process and operational plans of factories that are included in that industrial symbiosis to have good decision making. Because sometimes the distribution of some service, material, energy from one factory can be stopped because of some malfunctions in that factory. So if they stop, that means the other factory will have no supply of those materials, energy, etc., and they must react in time on time to have no further problems in their production system. When all those, let's say, administrative or design of the project parts are finalized and everything is looking good, we need to start with the implementation of the project. We are starting with installation of required equipment, sensors, flow meters, Ethernet, etc., and establishing a two-way connection between physical and digital systems. After that, we need to test the system. We are getting the first results for the function of created digital twins, and after testing, we can improve. We can do improvement if the test is not satisfying, or if test is satisfying, we have already created digital twins.
Sorry, your time is finished. Please try to summarize and conclude.
Okay, thank you. So we create a final digital twin model, and now what are the benefits for implementation of industrial symbiosis? Those are reduced time to design and to market, reduced waste during manufacturing, reduced energy consumption, reduced raw material consumption, improved performance monitoring, maintaining optimal operations, and reduced cost of maintenance of machinery and elimination of downtime, maintaining implemented housing and shipping of finished products, improved collaboration between teams, and improved safety. Thank you for your attention.
Okay, thank you for your presentation. Dear participants, do you have any questions about this presentation? Okay, let's go on with the next paper. The title of the paper is Data Complexity-Oriented Classification of Multispectral Remote Sensing Imagery via Machine and Deep Learning Approaches. You can share your screen.
Okay, good morning, everyone. My name is Berrin İşlek. I am research assistant from Department of Computer Engineering of Sivas Science and Technology University. Today I will present our study on paper titled Data Complexity-Oriented Classification of Multispectral Remote Sensing Imagery via Machine and Deep Learning Approaches. The purpose of this study, we classified the land cover of agricultural area at the field level using multispectral satellite images. The main purpose of this research is to evaluate different classification methods considering data, computational and information complexity. We also used hierarchical clustering for data labeling and applied object-oriented classification using deep neural network, random forest, and support vector machines algorithms. Multispectral remote sensing data. The multispectral image employed in this research was obtained using the Landsat thematic mappers and depicts agriculture region situated in the Seyhan Plain in Adana, Turkey. The image spans area of 198 by 200 pixels. Figure 1, Landsat thematic mapper image without a prior information of the agriculture regime. Figure 2 shows a Landsat thematic mapper image of the study area in corresponding the previously collected parcel information. Control file codes and data labels. 5 major land cover classes with potato, vegetable garden, citrus, and bare soil are present in the region with a total of 25 subcategories. Based on this classification, 25 control files have been defined within the area. Data complexity analysis. The multispectral image data analysis in the study were actuated using the Landsat thematic mapper sensor. LED bands 3, 4, and 5 values denoted by variables x1, x2, and x3 respectively. There are 39,600 instances surrounding and 198 by 200 pixels variable matters for each variable. The method for determining the degree of data complexity is based on hierarchical structure of all groups, clustering in data. Feature 1, hierarchical trees structures of all groups. In the first feature, X1 for remote sensitive multispectral image data complexity. Figure 2, hierarchical trees structures of all group. In the second feature, it's 2 for remotely sensitive multispectral image data complexity. Figure 3, hierarchical tree structures of old group. In the third features X3 for remote sensitive multispectral image data complexity. And classification methods, deep neural network. Deep neural network is an advanced type of artificial neural network designed to capture complex relationship is in data through multiple layers of interconnected neurons. Inspired by the information processing machines of the human brain, DNNs consist of several hidden layers where each layer transforms output of the previous layer into increasingly abstract representations. Effective of DNN depends on several factors, including structural issues such as number of layers and neurons per layers, learning patterns such as activation functions, learning rate, number of epochs, batch size, and use of regulations methods. Random forest model is an ensemble learning technique that generated collections of decision trees, each trained, and random that generated collections of decisions tree, each trained, and randomly selected subsets of data and features. At every split within tree, only randomly choose portions of the available attributes is considered for determining divisions. Each tree products its own prediction for a given input and finds classification outcome obtained majority weighting across the ensemble. Support vector machine. Support vector machine model is a supervised learning algorithm. In Webnik's statistical learning theory, its main objective is to indefinitely optimal separation between classes. By using kernel function, SVM can project a training sample into a high-dimensional space, allowing into distance classes that are not linearly separatial in the original features space. The selection of kernel function is K design choose. Typical kernels include linear, polynomial, radial basis function, and sigmoid. This study radial basis function kernel is choose because of its effective in managing nonlinear separation tasks. DNN-based results. Deep neural network model was trained and tested multispectral remote sensing data was divided into training 80% and testing 20% subsets. Evaluation metrics for each class are present in a table, while the confusion matrix is provided in feature. DNN model actual and overall accuracy of 97% with average precision recall and F1 score also at 97%, indicating a strong and balanced performance across the data set. While the model performance were for most classes, some underrepresented classes cited lower recall values reflected misclassifications. Random forest based result. Random forest model achieved average accuracy of 98% with average precision recall and F1 score also at 98%, demonstrating strong and consistent performance across the data set. Although model performance exceptionally well, overall lower recall values were observed for some underrepresented classes, indicating occasional misclassifications. The confusion matrix illustrates the pattern of misclassifications, highlight the model's general strength and limitation. SVM-based results. SVM model overall accuracy of 95% with precision recall and F1 score. Also around 95%, indicating generically balanced and performance data set. While the model performance were for most classes, some underrepresented classes showed lower recall values, reflected misclassifications. Very small classes exhibit extreme metric values with some perfect due to overfitting rather than predictive capability.
So your time is finished. Please summarize.
Accuracy, precision recall, and F1 score are calculated from confusion matrix result. The overall accuracies of SVM, RFC, and DNN are 96%, 99%, and 95% in tables 1, 2, and 3 respectively. As explained, the best classification around result calculation from the DNNs 95% due to data complexity. The find of this study indicate that when the data complexity is low, classification can be effectively performed using machine learning technologies, whereas high data complexity may require utilization of deep learning approaches. Thank you for listening.
Okay. Thank you for your presentation. Are there any questions about this topic? Okay, let's go on with the next paper. The title of the paper is Customer Review Summarization in Product with Large Language Models for E-commerce Platforms.
Good morning, everyone. Can you see my screen?
Yes, there is no problem. You can start.
Okay. I am Bahadır. I am a leading data scientist in Hepsiburada, and today I'll present you our study on the building a large-scale customer review summarization system at Hepsiburada. Today I'll focus on the practical challenges and the architectural decisions involved in developing and deploying this application to a large-scale e-commerce company, to web. And also we will share our experimental setup and evaluations also. And finally, we will conclude and share our future direction. Basically, the core problem we are solving by this research and study is the information overload. While customer reviews are a vital component in e-commerce, too many of them can actually overwhelm a user and basically slow down their decisions to buy a product and purchase that product. And basically, by using this review summary feature, review summary study, we use an LLM-powered system, and we provide customers to users a concise and unbiased review summaries, so that they can find the information they need faster, and they can finalize their decision to buy or not. And this is two examples from the current live system. One is an LG television and the Turkish summaries for that. And the other one is the Samsung Galaxy S25, a new telephone. And basically, this is the review summaries we are showing the customers in the live system. The core contributions of this study is basically, well, we have three core contributions. We we provide a detailed look at deploying a generative AI system, an LLM-based system at a large scale system in Hepsiburada, like Hepsiburada. The second one is actually a novel and cost-driven architecture that balances both the output quality as well as the operational cost, since the LLMs are not a cheap solution when you think about it. And finally, we also come up with a robust evaluation framework for generating text outputs from actual customer reviews. And even though in many summary generation research literature, many researchers users ROG as a metric. In this case, or ROG-like metrics, we decided to not go with that due to the empirical and human-based after the human-based evaluation, and we decided to use LLMs as a judge in this specific architecture. So basically, okay, the main problem with the review summary research is basically there were many LLMs out there like GPT-5, Gemini 2.5 Pro. The problem is the big and better LLMs are too expensive. And by the way, since Hepsiburada is a Turkish e-commerce company, one of the main concerns we had was the LLMs must also work to understand and generate Turkish text. So also the cheaper ones compromises the quality in terms of the review quality as well as the language quality too. Hence, we decided to we decided to tier the summary generation part. Basically, for the high impact products, by high impact, I mean the products or product types that bring more revenue to the company, we decided to use bigger LLMs like the Gemini 2, GPT-5. And for the rest of the products, since we have millions of products, we decided to use more cost-effective LLMs. And again, since we have millions of products, obviously it is not possible to evaluate all the reviews generated summaries by hand or with human annotators and then push them into the live system. So we decided to use this LLM as a judge model to evaluate every single summary generated against a strict set of rules and metrics. And according to the quality score we got from that judge, we decide whether to use the generated review summary in the live system or not. And the below is our architecture eventually. So basically, we get the products and the corresponding customer reviews for that products. And first of all, we decide whether that product is an eligible product to generate a review summary. Because not all products generated equally, as well as not all products have enough reviews to generate a summary. So basically, the main rule is a product must have at least 10 or more customer reviews to be able to this system to generate a concise and unbiased summary. Then obviously some products have also thousands of thousands of reviews, as well as not all of those reviews has necessary information or product related informations. And we decided to build a half intelligent sampling algorithm while keeping the customer review score distribution as much as similar to the whole review summary population. We aim to get the reviews that has the most information related to the products. Then, according to the product type's importance, according to the business, we generate the summaries by using a small or bigger LLM ones. Then we evaluate the summary by using, in this case, we are using GPT 4.1, by the way, as a judge. And then we check the final quality score of this first generated summary. If the quality score is not enough, if it cannot pass the threshold scores we gave to the system, we basically rewrite the summary and we reevaluate the summary. And then we again check the quality of the rewritten summary. But obviously, this is not an infinite loop. After 2 trials, if the system cannot provide a quality review summary, we move on and we don't push those summaries to the live system. But if the quality score is higher than the threshold, you will able to read them in the system. So to evaluate the summaries, we basically need to be able to decide which LLMs to use. We set up a test environment so that we can identify the best LLM alternatives in terms of cost, in terms of latency, and in terms of the quality, and also in terms of the language quality too. And for this test set, we get 1,000 products on sales from the Hepsi product catalog, a diverse set of products, by the way. And we compared GPT 4.1, Gemini 2.5 Pro, and Gemini's Flashlight Model 1. Also, we used Trendyol's public LLM solution. By the way, Trendyol is our competitor company in Turkey, and yes, we also tested their LLM too in our case. So the first 3 model, obviously commercial ones, not open source, but they are closed sourced, and the Trendyol's LLM is an open source LLM solution, by the way. And for the metrics, by the way, these are the metrics that we are also using in our judge. We create a quality score that is between 1 and 10. And this quality score is a weighted addition of the helpfulness, factuality, relevance, coherence, and compliance components. Basically, the helpfulness is whether the summary aids the customer purchasing decision. In the factuality metric, we check whether LLM generated a hallucinated version of the customer reviews. For instance, it can generate unwritten or unmentioned product properties. It can provide positive or negative feedbacks to the according to the non-existent customer reviews. And the relevance is also reflect whether the review reflects the main ideas in the sampled set of reviews.
Sorry, your time is finished. Please try to summarize.
Okay. Then let me finalize with this. Of course, we in the quantitative base, GPT 4.1 and Gemini 2.5 Pro provided the highest LLM and human annotator scores. In the human annotator case, we evaluated the generated reviews to humans. And as you can see, the reviews, both human and LLM scores are somewhat closer. So we can also say that the LLM as a judge solution provides human-like quality scores too. And these are the qualitative results, but you can also read them in the paper too, so I am passing them faster. As a result, we decided to move on with the GPT 1.4.1, even though the Gemini version provided the best scores, but the GPT version, OpenAI version, provides more consistent neutral tones and has a more lower latency, as well as the cost of it is less than the Gemini version. And for the cost-effective part, again, we go with the small Gemini version because Trendyol's LLM couldn't generate, as you can see, good reviews in most of the cases while we tested. And these are the future works. We will get human feedbacks from the customers to improve the reviews. Also, we are aiming to personalize the summaries by using the reviews with images and videos too. And thank you for listening.
Thank you for your presentation. Are there any questions about this presentation? Okay, thank you. Dear participants, once again, I would like to remind you that all participants will have 10 minutes to present their studies. So the title of the next paper
Sorry,
is...
Professor, can I ask something? Can I present now? Because later I have a class and I would need to leave earlier. If it's fine for the next presenters also.
Dear participants, is it okay for you? I need to ask you.
It's okay.
Okay, then you can share your screen.
Okay, thank you. Just a moment. Do you see my screen?
No, we cannot see.
No? And now?
Now we can see.
Okay, just a moment. Okay, so hello everyone. My name is Anna Atanasova, and today I will be presenting the paper, The Environment and Wind Energy Production by Analyzing Noise Filtering in Wind Signals to Improve the Efficiency of Energy Systems. So first, I would like to introduce what we are going to talk about. And the topic is that noise filtering is one of the most critical processes for enhancing the accuracy and efficiency of the signals captured by wind sensors, which are used to monitor and optimize the performance of the wind systems. Wind signals are often contaminated by noise, which complicates the data analysis and the decision-making processes regarding the production and the maintenance of the turbines. Our research focuses on the application of digital filters and multiple models in order to see how from the past values of time series we can see and improve the signals in the future performances of the turbines. So first, I would like to address what is our research problem, what is the impact of the problem, why should the problem be minimized, and how we are proposing the minimization of the problem be done. So the problem is that the wind signals are often contaminated by noise and interference, which complicates the data analysis and the accurate decision-making processes. Also here, it's very important to say that the impact of this problem is that the noise that is coming from these wind turbines can have a negative impact of the energy production, but also on the residents that live nearby. These problems can be caused by various factors such as atmospheric turbulence, measurement resolution, sampling rates, instrumental and transmissional errors, and some obstructions that can happen in the traffic with the traffic effects. How we think that this problem can be minimized is by making wind turbines projects that are planned very carefully and are managed well, considering acceptable noise levels and distances from the residential areas. So here we are implementing 4 filters as our methodology, and those are finite impulse response filters, infinite impulse response filters, velvet transformation, and Kalman filters. So the finite impulse response filters are filters that have a finite impulse response, which means that they have a limited number of coefficients. These are usually used to filter the noises without actually affecting the original signal. Unlike the finite impulse response filters, the infinite response filters have infinite impulse, which means that they use infinite number of coefficients. These are better and more efficient than the finite impulse response filters, but not in every situations. Regarding these 2 filters, and we have the velvet transform filter. This one breaks the signal into multiple components that are more simple and that have different levels of frequencies. So when we want to filter the noise when we have nonlinear variations in the signals, these filters will be the best choice to use. Kalman filters are advanced algorithms for filtering the signals using multiple mathematical models to predict and to correct the errors in the signal measurements. Now I would like to talk about the experimental results of our paper. First of all, we had a data set, which was a wind speed data set. This one, the data set contained the data that was raw and the data that was filtered. The data set was obtained between 2019 and 2020, and the purpose of it was to be able to do, based on the results obtained in those years, to be able to do future predictions by implementing the models that we mentioned before. Also here important is to mention that the data was collected from wind turbines from Kosovo. So the objective of our project was to evaluate the effectiveness of different noise reduction methods in enhancing the quality of the wind spin signals by analyzing data and quantifying the impact of the noise using statistical methods. In order to assess the performance of each noise model that we proposed, we did some visualization where we are comparing the actual raw data and the data between the models. So by plotting the actual energy production against the predicted values generated by models, we are gaining valuable insights into the stability and the accuracy of the models, and at the end we can decide which of the models that we proposed is having the best results. So the findings are showing that the closest the match indicates that model is more accurate and suggests that while the greater differences between suggest that the model is not doing effectively and replicating the energy production trends. Here in this photo, we have our raw data analyzing. So we have visualized the plot and observing the presence of the noise. As we can see here, just a moment. We can see here that the data exhibits significant fluctuations. So we can notice that we have presence of noise. In reality, these fluctuations are not characteristic for the true wind behavior. So we have underlying wind patterns that are crucial for accurate analysis. The first analysis we do are with the fear filter, and the blue line represents the original wind speed, where the red line represents the fear filtered wind speed. And the result is that the fear filter effectively removes the high frequency noise while keeping the important parameters of the wind speed. Here we have the second filter, and the blue line represents again the original speed measurements, while the green line represents the the measurements obtained using the IIR approach. Here we can see that compared to the previous filtering, this filter provides a smoother response, but it might introduce some phase distortion. It's more subtler next to the previous filter and provides better frequency response with fewer coefficients. Here we have the wavelet denoising filter, and again we have the original readings and the noises, the noise signal. So the velvet denoising works by decomposing the signal into multiple frequency components and selectively removing the high frequency noise. Unlike the previous filters that we've mentioned, this one is particularly useful for signals that are non-stationary and have noise and trends over time. The Kalman filter, we can see that that's represented by the red line here. This one dynamically adjusts the predictions based on the past values and measurements, and it's making it particularly effective for tracking time series in the wind data. Unlike the FIR and the IIR filters that rely on predefined coefficients, this one is able to adapt to incoming data, which is caused later to reduce noise while preserving the underlying trends. If we compare the four filters now, we can see that the finite impulse response filter is ideal choice when the signal integrity is a priority. This filter, as we already mentioned, uses fixed coefficients and rely only on the past input values. Compared to the IIR filter, is more expensive and is less suitable for real-time application where the computational efficiency is crucial. The IIR filter is efficient in removing the unwanted noise using fewer coefficients, and which makes it perfect for real-time applications where the resources are limited. The output depends on the current and on the past outputs, which enable stronger noise reduction effect for lower cost, but it has downside, which is phase distortion in instability. The velvet transform filter decomposes the signal into two different frequency components, allowing selective noise removal, adapts different frequency bands, ensuring that the essential components of the signal remain intact. But this filter has one limitation, and that is that can introduce distortion in regions that have more sharp signal transitions. The Kalman filters dynamically adapt to the changes of the system, and the advantage is that the ability to minimize noise while preserving the true underlying signal. Also, it has a disadvantage, which is a higher cost, and it requires some additional knowledge in order to be able to produce the noise characteristics. So as a conclusion, we will say that noise filtering is one of the essentials for improving the quality of the wind data. It is very important where the wind turbines will be placed, and if there are some neighborhoods nearby which might impact negatively of the life of the people living nearby them. The environmental conditions are also very crucial, and in order to improve the wind prediction and how and where to place the turbines, the digital filtering methods and machine learning and AI can be used in order to have more reliable forecasting. So we have the references, and thank you for your attention. Feel free to ask if you have some questions.
Dear participants, do you have any questions? Okay, let's go on with the next paper. The title of the paper is a novel method for word segmentation and spell correction in e-commerce search engines.
Sorry, I have a problem with sharing screen. I have to quit and come back for a minute. Can you see my screen now?
Yes, we can see.
Good morning, everyone. My name is Mohammed Berakay, and on behalf of my co-authors from ICEEECS2025, I am excited to present our paper, A Novel Method for Word Segmentation and Spell Correction in E-commerce Search Engines. Let's start with the problem that is extremely common in e-commerce search. A user wants a black shoe, but types black shoe as a concatenated single word. This simple error, often caused by fast mobile typing, can easily break a search algorithm, leading to poor results and frustrated users. Our paper proposes a solution to this. We have developed an edit distance-based algorithm that uses a custom dictionary of words and statistical methods. The result is a system that achieves real-time correction and segmentation of these search terms. While we optimize this on our own real-world e-commerce data, the core approach is generalizable and can be adapted by other platforms facing the same challenge. Our primary goal was clear: to improve search accuracy and, by extension, user satisfaction. To do this, we had four main objectives. First, to specifically address the frequent errors we saw in our system's logs, namely word concatenation and basic spelling mistakes. Second, to enhance product discoverability. Users should be able to find what they are looking for, even if they make a typing mistake. And third, the solution had to be fast and reliable. A search suggestion that takes 5 seconds is useless in a real-time system. And finally, we wanted to create a generalizable approach so that it could be applied across different platforms, not just our own. To build a data-driven solution, we started with our own system's data. We sourced 6 months of search logs from our Hepsiburada e-commerce platform, giving us a large pool of search terms and their frequencies. We filtered this data significantly, keeping only terms that were searched at least 10 times to remove the long tail noise. We then ran a thorough cleaning process. We removed symbols, emojis, duplicates, and other meaningless entries. After all this processing, we were left with a high-quality, clean dataset of approximately 10 million search terms and their frequencies, which became the foundation of our model. The diagram on the right shows our overall search research flow. It all starts with the user search queries. After cleaning and filtering, as I mentioned before, the first critical step is dictionary creation, where we build our unigram and bigram models. From there, we evaluate two different methods for solving the problem: a compound search method, as we name it, and a word segmentation method. We first compared them on a spell checking task to find the best parameters. Then we ran a final comparison on our main task of segmenting compound words. As you can see in the diagram, the word segmentation method was ultimately chosen as the best performing approach.
The dictionary is the heart of our system. As I mentioned before, we didn't just use the raw queries as is. We first generated all unigrams and bigrams from these terms. We then calculated their frequencies by distributing the frequency of a full query, like black shoe, across its component words, black and shoe. This allowed us to build and test 3 different dictionaries. First, dictionary WA. It contains full search terms from our system with their frequencies. It could be over 3-4 words. Dictionary OU contains only unigrams from the search terms. So for a term like black shoe, it contains black and shoe separately and does not contain the whole term in the dictionary. And finally, dictionary UB. This is a combination of unigrams and bigrams from the search terms. Before we could compare our 2 main algorithms, we had to find the optimal parameters to compare those. We ran an extensive evaluation on a spell checking task instead of compound word task to tune the parameters. We tested 5 key variables which will be used in both of the methods to be compared. And we have 2 search frequency thresholds, SFT and USFT, to filter out noisy low frequency words. We have maximum edit distance to control how far a correction can be from the original. We have prefix length, which is the length of word prefixes used in spell checking. And finally, and most importantly, the use dictionary, whether to use one of the 3 dictionaries I've mentioned before. Table on the right shows the best results from many variable combinations we tested. As you can see, the dictionary UB, the one combining unigrams and bigrams, consistently provided the highest F1 and accuracy scores. This confirmed that having bigram data was critical, and we used this dictionary and the best variable values in the top of the table for our final method comparison. The first method, as I mentioned, was the compound search method as we named it. Let's quickly walk through it. First, it tokenizes the input and excludes any numbers or abbreviations. It then generates candidates from the dictionary using Levenshtein distance, prioritizing those with a low edit distance and high frequency. Next, it performs a word merging analysis. It checks if combining 2 adjacent words like app and pill into apple, and if it exists in the dictionary and has a lower overall error cost. It also does the opposite of it. It checks if combining 2 adjacent words, if a word is unknown, it tries splitting it every possible point and evaluates the resulting bigram's probability. For example, if black shoe is written concatenated, and it checks at the letter K, and if splitting there results in a lower error cost. Finally, it scores all these potential candidates based on both edit distance and bigram language model probability and selects the single best correction. Second method was word segmentation method. This is based on a paper written by Wolf Garbe in 2019. It uses a dynamic programming approach to find the optimal way to split a concatenated string into a series of valid dictionary words. It iterates through the word, and at each position it considers all possible word prefixes to explore the different ways the string could be segmented. It scores every possible segmentation based on the unigram probabilities of those segments. The winning segmentation is simply the one with the highest total probability, which is calculated as the sum of the log frequencies. So which method won? This table shows the final head-to-head comparison on our concatenated word test set. The results were very clear. The word segmentation method outperformed the compound search method we built on all 4 metrics: precision, recall, and accuracy. This was a nice outcome for us since it meant that the simpler, faster, and more efficient algorithm was also the more effective one for our specific problem, and it could be very well used on our real-time system. But our work isn't finished yet. As the next step, we have 3 items. First, we want to do A/B testing on Hepsiburada. We need to move this from a research environment into a live production test to measure its real-world impact on user behavior and conversion rates. And secondly, we are exploring LLMs for compound word detection. While our dictionary method is fast, but large language models are much better at understanding context, and we believe they can help us detect when to apply segmentation more accurately. And finally, we can create better dictionaries, which is the core of the algorithms. And so better dictionaries means better results. We can continue to iterate on it, enriching it with more domain-specific data to improve performance even further. Thank you for your attention. I will be happy to answer any questions.
Okay, thank you for your presentation. Are there any questions about this topic? Okay, let's go with the next paper. The title of the paper is NLP-based query interface for InfluxDB, designing a hybrid architecture with space and large language model.
Greetings. I will be the presenter.
Okay, you can share your screen.
Okay. Is the screen good?
Yes, you can start.
Thank you. Hello, my name is Fatih Kaya, and I will be presenting NLP-based query interface for InfluxDB, designing a hybrid architecture with spicy and large language model. Digital technologies have fundamentally changed social and economic structures in the 21st century. This process of change is known as digital transformation, that is a process aimed to improve an organization or system. However, this transformation involves more than just adopting new technologies. It also requires fundamental rethinking of business models, operational processes, and methods of creating value. Digital transformation has led to loss of new data, which helps with making strategic and operational decisions. But this whole big data isn't just about the amount of data, it also includes a wide range of data diversity, speed, and complexity. This wealth of data provides a significant competitive advantage when analyzed correctly, but unlocking this potential stored in databases often requires advanced technical expertise. The lack of this ability makes it hard to access data and information. To address this need, natural language interfaces were developed. These interfaces allow users to interact with databases using natural language instead of structured query languages. This idea is actually not new. It has a long history dating back to early computer science research, such as the lunar system. When a user submits a query, it first passes through the parser, which analyzes the grammatical structure of the sentence using the grammar and dictionary components, as can be seen in screen in the figure. Next, this structure output is sent to semantic interpreter, which focuses on understanding the meaning of the query. The translated query is then passed to readable component, which interacts directly with the database. This component formulates an proper database query based on interpreted meaning and retrieves the relevant information. Actually, the system was very old. It goes beyond the 1872. To address these limitations, NLI technology has developed significantly over several decades. Early version used keyword matching methods, which focused on linking user terms with existing database schema. As technology advanced, new systems evolved. To represent the relationship between entities and their attributes, knowledge graphs can be used. In this diagram, each node represents an entity while connecting arrows show the relationship between them, like the movies and their actors and their other relations can be seen on screen. By capturing these relationships, knowledge graphs allow systems to understand, reason about the connections between concepts rather than relying on keyword matching. Here is working like that. If we ask the systems what are the cities speaks French, let me say. So we didn't say anything about the city name, but we say about something like spoken language. So it has a relationship that city and spoken language. So if we search for the spoken language, it can directly tell the city names from the graph structure. Integrating LLMs expand the capabilities of analyze, allowing them to work with not only traditional relation database, but also wider variety of data models. This research has introduced several innovative approaches, as can be seen on screen. For instance, some methods improve semantic interpretation accuracy by integrating SQL grammar into neural networks. Other approaches involve developing multilingual frameworks that support multiple database engines by generating synthetic data. In addition, chatbots are being developed to translate natural language queries for graph database into specialized languages, such as Shipper. The system developed in this study is based on a hybrid approach that combines two distinct AI models within a single architecture. The first phase, query generation, utilizes rule-based and grammar-driven NLP techniques using SPICY, while the second phase, translating results, enables the reasoning and text-generating capabilities of LLMs. By using this method, deterministic and reliable results can be produced. Also from the raw data, human-like explanations are being extracted. The following methodology separates the different cognitive tasks, which are query understanding and result interpretation, allowing the most proper approach to be selected for each. The first task, deterministic query generation, requires high accuracy and repeatability, meaning the same language input must always produce the same query. Because LLMs are probabilistic and carry risk of hallucination, they are unsuitable for this task. Therefore, the study used the SPACE library, which provides a rule-based and predictable method for parsing text structure. In contrast, the second task, generative response interpretation, involves generating human understandable insights from structured numerical data. Here we can see the developed system architecture on the screen. This system uses a design model similar to layered pipeline architecture. This architecture consists of independent components where each component has a specific and defined responsibility. The system takes natural language input from the user and follows a data flow through for main components until it produces natural language output. Each component passes a standard data structure to the next. This architecture follows a sequential pipeline structure that takes the natural language input, processes it, and produces natural language output, which a human can clearly understand. The process begins when the user provides text-based input to the natural language parser. The first component analyzes the text to extract user's intent and critical entities like measurement, time, and then converts this analysis into structured JSON object. This JSON representation is then fed into the Flux query generation component, which synthesizes it into valid Flux query that the InfluxDB database can understand. In the pipeline's second half, the query executed on InfluxDB, returning raw data. The data in CSV format is then converted into structure as pandas data frame for statistical analysis. As a final stage, this structured data is provided as input of the Llama 3.1, which serves as the interpretation engine. The LLM analyzes the quantitative data within the context of user original query and produces the final natural language response. Completing the cycle from natural language input to understandable natural language output. Here we can also see the process of prompting a query into database. It is starting with the user asking the question, what is the average of counter field for the bold DB reads total metric? So when the question asked from the fast API server, which is running locally on the server, the NLP parser space is parsing the task and recognize the entities as can be seen in also figure, like measurement is both DB reads total and field is counter field. So then it creates a query which InfluxDB can execute and respond. So after query generation, data is retrieved by data access service, which is also running locally on the localhost machine. So then this response is sent to Llama 3.1 LLM model. It is basically in numeric format in CSV file, like the timestamp and the value of the data. So it is still complex for a human to understand. Llama executes some mathematical operations and also interpretations to make the query become human understandable. As a result of this process, it responds to the user. We see that the average value is approximately 173.07. So the query is ending like that. Outcomes, there are basically
Sorry, your
two.
time is finished. Please try to summarize and conclude.
Okay. As an outcome, there are basically two outcomes, which is successful and failure case. The system is basically being successful if this query exists in predefined dictionary, and it is not being successful. It is a failure case if this verse not exist in the dictionary. As a result, the system clearly prefers not to answering the question rather than hallucinate an unfamiliar topic and generating incorrect query. This is actually very important and desirable for critical monitoring systems. Thanks for listening.
Okay, thank you for your presentation. Dear participants, do you have any questions? Okay, let's go with the next paper. The title of the paper is Emotion Recognition Using Machine Learning Models on EEG Signals.
Can you see my screen?
Yes, we can see, and you can start.
Thank you. Hello, my name is Gizem Yıldız. I will present our study titled Emotion Recognition Using Machine Learning Models on EEG Signals. Emotion is a complex psychological and behavioral response to internal and external stimuli. It plays a crucial role in human communication, reflecting both mental process and psychophysiological states. Emotion recognition research aims to identify emotions using various modalities such as body language, psychological signals, and audiovisual cues. Recent studies have focused on the three main categories of automatic emotion recognition. These are observational methods, peripheral signals, and neurological signals such as EEG and ECOG. EEG is a non-invasive technique that records the brain's electrical activity through electrodes placed on the scalp. In EEG, brain waves appear as characteristic zigzag patterns that provide valuable insights into cognitive functions and neurological disorders. The properties of these waves vary across different states of consciousness, such as sleep and wakefulness. When neurons fire synchronously, their combined electrical activity becomes measurable from the scalp. EEG was first discovered by Hans Berger in early 20th century and has since been studied in relation to various brain functions. The most common criterion used in classifying EEG waves is their frequency. Based on their frequency values, EEG waves are divided into four main groups. These are delta waves, theta waves, alpha waves, and beta waves. The distribution of these wave types is evaluated according to an individual's age, state of consciousness, and neurophysiological context. In this data set, the Muse headband used. Muse is a portable headband designed for recording EEG signals. Although primarily developed for meditation and mental wellness tracking, it is also widely employed for monitoring emotional states and in neurological research. Most Muse models record brain waves using 4 to 7 channel electrodes, typically positions over frontal, parietal, and temporal regions of the brain. In academic studies, Muse is frequently preferred device for monitoring emotional responses, analyzing the brain effects of meditation, and assessing states of attention. We use EEG brainwave dataset filling emissions. This dataset was used in the study to classify discrete emotions. In this dataset, participants watched segmented video clips designed to elicit three types of emotions: negative, neutral, and positive. For each emotional state, 6 minutes of data were recorded from two adult participants, one male and one female, aged 20 to 22, both highly educated STEM students, resulting in a total of 36 minutes of brainwave activity. Muse headband used to collect data from extranuncial electrodes placed at TP9, AF7, AF8, and TP10. In this way, human emotions were elicited through visual stimuli and corresponding data were recorded from EEG sensors. For negative and positive emotions, 6 different clips showed the participants. These are death scenes and funeral scenes from Marley and Me, Up and My Girl movies. For positive emotions, the musical scenes from La La Land movie, nature time-lapse videos, and funny dog clips. In this study, various machine learning algorithms were used to classify the emotional state of individuals based on the EEG brainwave dataset. When we look at the past studies of this dataset, J.J. Bird, who is also the creator of the dataset, extracts statistical features from the EEG signals for alpha, beta, theta, delta, and gamma frequency bands. Feature selection was performed using methods such as one-layer Bayesian network, information gain, and symmetrical uncertainty. Original dataset consisting of 2,548 features, reduced using the 63 most relevant features selected by information gain. Ensemble classifiers such as random forest trained on these selected features achieved an accuracy of approximately 97% and DNN reached 94% accuracy. In 2022, Joshi and Joshi achieved high classification accuracies using EEG signals by DW2 and RNN in order 94% and 93%. In 2023, Miralda et al. Performed emotion classification with high accuracy using various deep learning models, achieving 98% with DNN, 97% with LSTM, and 97% with GRU. Dara et al. Achieved accuracy rates of 96% for valence and 97% for arousal using CNN LSTM-based hybrid model. Hybrid architectures in particular stood out in the feature extraction directly from raw EEG signals. In 2024, Ranini et al. Employed various machine learning models in their study, achieving high performance with random forest 99%, SVM 98%, and KNN 94%. In 2025, Parkash and Palus compared 8 different supervised algorithms. XGBoost model achieved the highest accuracy, 92%, followed by CatBoost model, also 92%, and LightGBM, 91%. Naive Bayes algorithm showed the lowest performance with the accuracy of 72%. Here we can see the block diagram of our model. Before training the models, we applied several pre-processing steps to the data. At first, we converted the categorical emotional labels into numerical values so that the algorithms could process them properly. Next, we performed normalization to bring all future values into similar range. This helped prevent bias caused by large differences in scale and improve the learning process. Finally, we use PSA for dimensionality reduction. This helps us to eliminate the redundant information, highlight the most important features, and speed up the computation. After pre-processing, the data was ready to be trained with several machine learning algorithms. In this study, we used models such as LSTM, GRU, DNN, SVM, XGBoost, logistic regression, and random forest. Each of these models has unique strengths in capturing different patterns within EEG signals, helping us better classify emotional states. In this table, we can see the performance metrics of the used machine learning models. Also as seen, the GRU model has achieved the best results with 97%, and all the models have achieved successful results, all of them above 94%. This table compares our results with studies in the literature. Looking at the table, we can see that the GRU, XGBoost, and RNN models achieved better results than this in the literature, while other models achieved results similar to those in the literature. Among the models tested within the scope of this work, the GRU exhibited the highest classification accuracy. These results suggest that the GRU performs exceptionally well with signal-based data due to its ability to effectively learn time-dependent patterns. Specifically, the GRU's capacity to achieve a learning capability similar to deeper architectures like LSTM with fewer parameters allows it to optimize training time while simultaneously enhancing classification performance. In this context, we can conclude that the GRU offers an effective and efficient model alternative for applications like emotion analysis that involve high-dimensional data with time series characteristics. In this study, the experimental work was conducted on the subject of EEG-based emotion recognition, and current literature was revived. As demonstrated, machine learning models yield promising results, classifying emotional states with high accuracy rates, even when using low-cost EEG device. However, critical challenges remain to be addressed in this field, including the inherent susceptibility of the signals to the noise, significant inter-subject variability, and difficulties encountered in real-time applications. In future works, we aim to focus on the development of more flexible and reliable systems through the multimodal approaches, more advanced and personalized models, and the integration of explainable artificial intelligence. This is the references. Thank you for listening to me. If you have any question, I can answer.
Okay, thank you for your presentation. Are there any questions? Okay, the title of the last paper is Recognition of Mushroom Species Using Few-Shot Learning Method with a CMS Network.
Hello, Professor. I will share my screen.
Okay.
Could you see the presentation?
Yes, we can see and you can start.
Okay, thank you. Good morning. I am Göktürk Öztürk from the Department of Electrical and Electronics Engineering. I'm pleased to present our study titled Recognition of Mushroom Species Using Few-Shot Learning with a Siamese Network, which I conducted together with my supervisor, Professor Köksal Erentürk. Here is the content of our presentation. In this talk, I will briefly describe the motivation, the methods we used, and the main findings of our work. Let's continue with the motivation part. Mushrooms are widely consumed for their nutritional and medicinal value. However, toxic mushroom species can cause severe poisoning and even be fatal. The challenge is that many edible and poisonous species share similar physical characteristics. For example, if we wandering in nature, we can see the two white mushrooms. They could be similar, but they have tiny differences. So we have to know if it is poisonous or edible. So we thought that we can use the artificial intelligence for this problem and deep learning techniques. But traditionally, mushrooms are identified by experts through morphology, which is time-consuming and prone to human error, need for automated, reliable recognition systems. This is the photo of chanterelle, or in Turkey, we call this chicken mushroom or egg mushroom. This photo belongs to me also. Research gap, we thought that the limited perspective of limited dataset, CNN-based models and transfer learning approaches have achieved high accuracy in mushroom classification tasks. However, these models usually require large, balanced, and well-annotated data sets, which are often unavailable for mushroom species. So we thought the few-shot learning method and the harmony of the mushroom recognition problem. Few-shot learning has been successfully applied in numerous fields where data scarcity is a critical problem. Despite its suitability, it has not yet been systematically explored for mushroom recognition, which suffers from similar data scarcity challenge. And existing studies about the mushroom classification are very few evaluated models under low data regimes. Our objectives is here. The main objectives of this research were to apply a Siemens network with ResNet 18 backbone for recognizing mushroom species. By the way, we prefer ResNet 18 for faster processing. The second one, 7-way 3-shot learning. Why we used 7-way 3-shot learning? Because the balanced and realistic evaluation scenario, 7 classes were chosen to represent sufficient interclass diversity, while 3 support samples per class ensure limited data conditions typical of few-shot learning. This setup allows the model's generalization capability to be effectively assessed under data scarce environments. The third one, cosine embedding loss, computes with this cosine embedding loss similarity score. We can calculate the similarity score between embeddings. Finally, we want to get the accuracy, precision, recall, F1 score, and confusion metrics to evaluate the model. The original data set is here. Here you can see the histogram of this data set. Maybe I can get a closer look. You can see the names of mushroom species here. There are total of 215 mushroom species, but also the data set consists of 3,122 mushroom images, which are not totally unique. So we needed to eliminate and organize the data set. Pre-processing of data set. Mushroom data set was organized by species and divided into training, validation, and test subsets. For the few-shot setting, we adopted a 7-way 3-shot setup, which I talked about earlier. So we can test the model's generalization under limited data condition. All images were cleaned by removing the backgrounds to make sure the model focuses on the mushroom's morphology, not the environment. You can see the background removal process here. The left side, the original photo, and the right side, the removed background photo. So we used total 336 images for training and 49 images for validation. Lastly, 72 images for test. Here are the percentages of images. Data pre-processing. Before training, all images were standardized to 224 by 224 pixels and normalized with ImageNet standards. To enhance the enhanced generalization, random flips, rotations, and color changes were applied during training. During inference, we kept only resizing and normalization to preserve consistency. Training phase and architecture. This phase first generates positive and negative image pairs from the data set and applies resizing, normalization, and data augmentation. During training, the model learns to bring embeddings of similar images closer while pushing dissimilar ones apart using cosine embedding loss. If the cosine value is greater than the 0.5, the images belong to the same class. Then we appoint that to +1 and bringing the embeddings closer together. If it is less than the 0.5, they belong to different classes, and we appoint them to -1 and pushing the embeddings further apart. Validation accuracy is monitored with early stopping, and the best performing model is saved as best Siamese ResNet 18. This complete pipeline ensures robust feature learning and reliable evaluation for fifth-shot mushroom classification. Hyperparameters and Siamese network have been given on the left side of the presentation. Here you can see. A Siamese network with a pre-trained ResNet 18 backbone was used for efficient and stable feature extraction. The final layer was removed, producing a 256-dimensional embedding from the 512-dimensional feature vector. Both images shared the same weights, and their embeddings were compared for similarity. You can see the train loss and validation accuracy graphs below the writings here. Fifth-shot inference. In this phase, we used best Siamese ResNet 18, which generated from the training process. In the 7-way three-shot setup, each query image was compared against 21 support images. For evaluation, embeddings were extracted for both support and query images. Cosine similarity was calculated between each query embedding and all support embeddings one by one. Classification was performed via a nearest neighbor approach, which means the best cosine similarity score between these 21 support examples, we pick this maximum value and we appoint this query to that support example. So we can say that this mushroom belongs to this mushroom species. Classification was performed via a nearest neighbor approach. Each query was assigned to the class of the most similar support embedding. Results are here. On the left side, there is a confusion matrix. You can see the Karkoral burner is misclassified as blue roundhead. There is the only misclassified process in this 7-way three-shot experiment. You can see the overall accuracy as 90.48%. Out of 21 query samples, 19 were correctly classified, while 2 were misclassified. 6 mushroom species, Beechwood thickener, blue roundhead, cow flower fungus, chanterelle, bulky milkcap, and yellow staghorn were classified with 100% accuracy. In contrast, as I mentioned earlier, Karkoral burner class exhibited weaker performance with a recall of 33.3, as 2 of its query samples were misclassified as blue roundhead. You can see the result. Also, we got the visual results with cosine similarity scores. You can see the predicted class and true class of each samples, and below of them there is a cosine similarity score. There is a misclassified example here and here. The main reason of this issue is the complexity of samples from Karkoral burner and the blue roundhead. That are quite similar. Maybe we use the wrong samples, but in the future works we will study about this. Discussion and future works. This study demonstrates the potential of applying fifth-shot learning to mushroom recognition, enabling effective classification even with limited training data. It extends beyond traditional convolutional neural networks methods by introducing a Siamese network-based approach for species identification To the best of our knowledge, this is the first application of few-shot learning for mushroom recognition. Future research can focus on improving accuracy by using deeper backbone networks, prototype averaging, more support samples, and advanced metric learning techniques to better distinguish visually similar species. Conclusion. This study shows that the Siamese ResNet 18 model can effectively perform fifth-shot mushroom classification, reaching 90.48% accuracy and perfect results for most species. Some confusion occurred between some species where their embeddings overlapped. Overall, the approach demonstrates the potential of few-shot learning for precise mushroom identification, improving food safety and guiding future research on better feature discrimination. Here are the references that I used. Thank you for listening to me. If you have any questions, I want to answer as possible. As of
Great. Thank you for your presentation. Are there any questions about this topic? Okay, I guess there are no questions. We have completed all of the presentations. Dear participants, on behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress, and we hope to meet you in next Congresses as well. Now I am ending the session. Thank you.